Hello and welcome to this lecture where we'll go into set operations in order for us to work with multiple queries. So let's move directly to the slides. So here, working with sets in SQL to manipulate and compare multiple queries. So let's start here with some theory. So set theory, we'll explain it using Venn diagrams. So you might have seen this already in mathematics studies, but this is very important in set operations in SQL. So you can see each set as it's a result set, basically. So what we can see here is this is an operation called intersect. So A intersect B. And so you have the result set from A and you have the result set from B. And the intersection is what is common in both of these result sets. So in SQL, you can see the result set as the two different tables which you get from two different select statements, right? And you can see each of the rows that are exactly the same, or each of the, each of the rows from each of the result sets. So only those that are exactly same will be returned here. If there is no that is exactly the same, then the intersection will be empty, right? So here is another one. It's called union. So we have A union B. So result set from A union the result set from B. So we get we combine both of them. So we get all of those rows. However, using the union, we will only get we will remove all the duplicates because of the sets operations. In general, we don't have duplicates. However, there's another operation called union all, which you can use, if you want to keep the duplicates. There's also except. So here, A except B, we have A here, and we remove the part that is that also exists in B, so that we only get those that are only in A, that is not in B, right? So A and B, they correspond to result sets from queries. So you will see that soon in some examples. And conditions for set operations is that we need to have the same number of columns and the corresponding data types. However, the column naming doesn't have to be the same. So remember, it has to be the same number of columns. For example, if there's 2 columns in one result set, then the other result set also need to have 2 columns. And the data type need to correspond. Otherwise, if it's not corresponding, then you cast a data type into another one. So let's combine rows from 2 result sets and removing duplicates. Then we use union for that, right? So here we have select star from synthetic.sales.jan, union select star from synthetic.sales.feb. So we see we have 2 queries that we combine, right? So we have 2 select statements that we are combining. And we see that we go select star from both of them. So we can look at the data. We can look at the data here. Here is sales Feb and here's sales Jan. Yes, I should probably have ordered them differently, but it's too late now. So what you can see is that they have same number of columns. We can also see that the data types corresponds. So it means that we can do this union operation. So remember that we remove the duplicates in the union, right? So here with the union, and we get same as here. However, how come the monitor, we see that monitor existed in both of the result sets. So this is one result set from the second one. This is the result set from the first one, right? How come the monitor is still there? Well, it depends on, we can see the sale date here. They differ, right? So that means that all of the rows are unique. So then they are just combined. And we can see that the indexes are it's really weird how they combine. And that is due to the optimization of how DuckDB does it. And if you're doing it in other SQL databases, then the database engine chooses which order they will put. If you want to have a specific ordering, then you should do order by. Otherwise, it's based on what is most performant. So that's why it differs. Okay, so moving on to union all. So now, instead of picking all the rows, all the columns, we only pick product name and amount. And in this, we see that, okay, so we're not picking these two outer columns here, only product name and amount. And here we can see that monitor and amount, they are exactly same, right? So monitor and 300, they're same in both of the result sets. So if we're doing union all, then we will get all of them with the duplicates of the monitor. If we didn't union here, then we would only get one monitor. So we can see here, these are duplicates, right? But we're using union all, so that is what we expect. So if we're doing intersection now, we get the common rows from two result sets. So we have similar here as before. And remember, what is the same here? What is the duplicates? Well, it's the monitor. And when we're doing intersect, it's the only one that is in common in both of the result sets, right? So we get the monitor back and nothing else. So we can remove rows that are in the other result sets from the first one using except, right? And here we select product name amount as before from both of them. So we get these two, and remember monitor is the same in both. So what we expect is that when we're doing except, the monitor will disappear from the result. So except, and the monitor row is disappeared. And it has disappeared thanks to, because it exists in the second result set. And it exists in the first result set, so it's kind of a set minus operator. Okay, and with this, I would like to thank you for watching this video, and see you in the next video where we'll go into coding part of set operations.